Hello class, this is Mr. McAllen, and I just wanted to review a few concepts that we did this week. We have our quiz tomorrow, and I just want to make sure that that you're okay with just a little bit of review for that. So we're going to start off. I want to try to do this in under 10 minutes, as I promised you. We're going to talk about radians or origin and how to use them. We're going to talk about also radians, how to find trig ratios using them, using our special trick that we did this week. And also we have degrees, how to find trig ratios for any angle using degrees and special triangles, and how to find trig ratios for quadrantal angles. So we're going to go through that rather quick. So what I'm going to do here on the first problem is I'm going to just work on with regular degrees as a review. So when you see that you have to do the sine of 120 degrees, the first thing you have to do is you have to draw your 120 degree angle in standard position, as we've done many times this week. So this is 120 degrees. We're going to then label our reference angle. Remember, our reference angle is an angle that is going to be with the terminal side and the x-axis, and we see that it's 60 degrees here, so then the opposite side will be root 3, that'll be positive. This side will be -1, because as vectors go, it's pointing in the opposite direction of the x-axis, and the hypotenuse will be 2. This makes our sine of 120 degrees to be root 3 over 2. Next one we're going to try is, let's do how about we do the cosine of 90 degrees, or -90 degrees. This will take us to our quadrantal angle. So you notice it's 90 degrees, or -90 degrees. It's going to be the angle that will fall in this quadrant line. So I'm going to draw that angle down in that direction. And remember, we said we have to make up our table for theta, and for sine of theta, cosine of theta, and the tangent of theta. Now we're going to come back to this table when we use radians, because we just have to make an adjustment to what the angles would be. And hopefully you remember from class today what the pattern is for this. We went over the Ferris wheel analogy, and so hopefully that sinks in with you. And here we go. I'm just filling out my table, so I'm going to put a 0 in there. Let me just make this red so that everyone can pick up on it. This is going to be 0 to start with, then it goes to 1, 0, -1, and 0. It goes through the pattern. Cosine starts out where at 0 degrees you have a 1 ratio. Then we go through the same pattern. And then tangent, remember, tangent is the slope of the terminal side, or it's the sine ratio over the cosine ratio. So we have 0, undefined, 0, undefined, or 0. So we're going to use that to help us out here to figure out the cosine of 90 degrees, or -90, whatever the case is. The cosine, when you're either at 90 or -90, is going to be 0. So again, -90 would be the same thing as a 270 degree angle. So that's why I can use that value also to show me what the cosine ratio would be. Let's just say, for one more example, I asked you for the sine of, let's just say, 270 degrees. Then you would go to the table again. You would know 270 would be there. You go to the table and you would notice that the sine ratio for 270 would be -1. Moving along, let's look at some other problems. So we come to the story of radians, and the story of radians is basically we want to have a measure of an angle that would be in terms of the radius of our circle. So we know that for any circle, we talked about this before, that if we have a radius, that as you go around the circle, you will fit approximately 6 radiuses in. And that's why we use the word radian, because it stands for how many radiuses. There are about 6.28 radiuses in one circumference. And we also know that formula is the famous 2 pi r formula. And that's why our central angle measurement for this angle in radians, this would be 1 radian, this would be another radian, another radian, another radian. So we have 1, 2, 3, 4, 5, 6 radians as you go around the circle. Now we've used that to help us figure out where we are around the circle. We know that at this point we're at 0 radians, and then we're at approximately 1.5 radians when we're at the vertical axis. Then we're at 3 radians on the horizontal, 4.5, and so on. Again, we've gone over this numerous times, and remember, these are approximate. We know the exact would be painted like this. This would be 0, this would be pi over 2 radians, this would be pi radians, 3 pi over 2, and 2 pi. And remember, when we want to approximate it, we replace pi with 3. So let's talk about finding the complement. Oh, I'm sorry, we should answer this question for number 6. Number 6 says, what is, give a positive and negative value for this point right here. Well, if I want to give a positive value for that, and I'm going to approximate it, I'm going to say that this is 1.5 at the top. I'm going to call that to be about 2 radians, or I'll call it negative 4 radians. If the angle is going to open up this way to it, it would be 2 radians. If it's going to open up in the negative sense, it would be 4 radians. So that's how I would answer that question. The next question says to find the complement or supplement of pi over 3. So what we need for the supplement is, the supplement formula is, the supplement will equal 180 degrees, or pi radians, minus pi over 3. We find our common denominator. That's 3 pi over 3 minus pi over 3. That gives us our supplement of 2 pi over 3. If we want to find our complement of an angle, let's say pi over 6, the complement rule is whatever angle they give you, it's got to add up to pi over 2. So we'll just take that angle away from pi over 2. So I'm going to do pi over 2 minus pi over 6. And I'll change the common denominators. So this will become 3 pi over 6 minus pi over 6. And that will give me 2 pi over 6, which is pi over 3. So that would be my complement. Now we're back to working with trig ratios. The cosine, I'm just going to clean this up. So I'll be back in a minute. Okay, so now the cosine of 2 pi. Notice that it's asking for the angle that exists on the x-axis. So what we do is we go back to our chart. Let me go back to my chart here. I'm just going to copy that. Hopefully it all copies in nicely. And I'm going to bring it down here to use it for reference. And there it is. But now I've got to change these values up top to be my radians. So I'll just change those. And I'm going to change them to what we were talking about in class today. This would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the cosine of 2 pi is going to be equal to 1. The tangent of 7 pi over 4, remember our trick. We said it's not a trick, it's actually logical. It makes a lot of sense, it's mathematically sound. It says that for a 4 in the denominator, it's a reference angle of 45. So now we just have to find out where negative 7 pi over 4 radians would be. So I'm going to approximate 7 times 3 is 21, divided by 4. I'm at 5 radians in the negative direction. So I am in quadrant 1, and I'm going to put my sides on. For the tangent, I have 1, 1, and root 2. So the tangent of negative 7 pi over 4 is going to equal 1 over 1, or just say 1. I'll do one more because I don't want to exceed 10 minutes, and I'm almost at 10-minute mark right now. So for 2 pi over 3, the 3 in the bottom tells me I have a reference angle of 60. We've practiced this many times in class, so I'm going to go to 2 pi over 3 is a 60 degree. It's in quadrant 2 because that's not quite 3 radians. Actually, 2 pi, that would be 6 divided by 3, that would be 2 radians. So that puts me, if this is 1.5 radians and this is 3 radians, I'm right in the middle. So the sides here would be would be 1. Oh, it's a 60-degree reference. So the opposite side would be root 3. This would be -1 and this would be 2. But the sine ratio of 2 pi over 3 would equal root 3 over 2. I hope you find this video to be helpful. I'm going to put it into a form. I want you to, if you can, just put your name down that you saw the video, and I'd like you to also just write a comment if there's anything on there that you don't quite understand or that you wish we would have more time to go over. Maybe before the quiz tomorrow I can talk about those things quickly. So anyway, have a good night. Also, be sure to, there's a more complete version of this review online that you can try on your own, but I just figured I would do a few problems just to sample. Take care. We'll talk to you soon.